Stem and leaf diagrams and histograms are two other displays that can be used for univariate data sets. So here's a data set where each number represents one point on the stem and leaf diagram. So a stem and leaf diagram takes the 247 data points and breaks them up into a stem of 4 and the 2 leaves of 7. Similarly, there were 4 73s and they're shown as 1 7 stem and 4 3 leaves. It's important to have a legend on every stem and leaf diagram. It tells you the meaning of the stems and the leaves. If you take the original stem and leaf diagram and rotate it, it looks actually a lot like a histogram. In this particular case, the shape of the distribution is fairly symmetrical. Here's a histogram, and here's a stem and leaf diagram of the same information. If you reveal the numbers underneath the histogram, you might ask, why would you ever want to use a stem and leaf diagram? People are more used to using histograms. Well, the main reason is that histograms are great for large data sets. Stem and leaf diagrams are better for small data sets. So the individual data values on a stem and leaf diagram are shown, but not on a histogram. The 5-number summary, mean, and standard deviation are not shown on any of them. The stem and leaf diagram is not really good for large data sets. You'd probably want n to be less than 150. Frequency histogram is good for large data sets. Stem and leaf diagram is great for small data sets, and it's, I would say, okay. A frequency histogram is okay for small data sets. The important characteristics: stem and leaf diagram, again, like a dot plot, displays the frequency distribution of small data sets, and it shows the minimum and the maximum. The frequency histogram displays the number of values in each interval. And that's an introduction to stem and leaf diagrams and histograms.